Hey smart people, Joe here. If you tried to sum up the last 150 years or so in one image, it might be this one. It's a chart of exponential growth, and it shows that some things change faster over time. You could apply it to life expectancy or compound interest or any number of things, but especially population growth. But back in 1798, a guy named Thomas Malthus noticed that not everything grows this way. Population growth was exponential, but how much food we grow was not. And this caused people to worry. Crikey, we're doomed!
Civilization's gonna collapse because of the weight of all these hungry people.
Yet here we are today because that collapse didn't happen. So how did we avoid that disaster? That answer is really important because people are doing this again.
Oh, cheerio.
And we have a new, even scarier disaster to avoid. The first time we defused the population bomb, it was mostly thanks to an agricultural level up known as the Green Revolution. And it's a big reason most people in the world have enough to eat today, at least for now. Because even though population growth is slowing down, now we have another new scary line to deal with: carbon emissions and climate change. There will be 2 billion more people on Earth by 2050, and 3/4 will be born where climate change is going to hit the hardest. And because a lot of the food that we grow feeds animals so that we can eat them, this much population growth actually means we'll need this much more crops. And this means farmers need to level up again in order to deal with droughts, floods, and generalized chaos while still feeding more and more hungry mouths. In the mid-20th century, Mexico, Africa, and much of South Asia faced starvation. A book called The Population Bomb predicted famines would kill hundreds of millions of people. But luckily, science came to the rescue before that could happen. Researchers, led by a guy named Norman Borlaug, bred new versions of crops like rice and wheat that resisted pests and gave larger harvests, which kept starvation at bay. Now, instead of crossing just a few plants together to try for a new variety, Borlaug crossed thousands and thousands using crop types from all over the world. Now, he found a wheat variety that made more kernels per plant and crossed it to make it shorter so those big heads wouldn't fall over. Norman and friends saved about 1 billion lives in the process. Yeah, with a B. Somebody should give that guy a Nobel Prize. Now, from the 60s to the 90s, rice and wheat yields doubled in Asia. Food got cheaper and more people got more calories and avoided dying. It was such a big deal, one farmer in India even named his child after a life-saving rice strain, IR8. How's the next green revolution gonna work? Well, some people think that we can hack plant biology to get out of this pickle, using modern genetic techniques to give plants new traits like drought, disease, and pest resistance. Genetically modified crops that contain helpful genes taken from other organisms are already common in places like the US and Asia, but debates over their environmental effects have kept them out of the ground in places like Europe and Africa. And while GM crops like pest-killing corn have lowered pesticide use by 90% in parts of the world, some bugs like rootworms are already developing resistance to the bacterial toxin inserted into the corn's DNA. It proves just how hard it is to stay one step ahead of nature. Many people think the next green revolution won't require this extreme genetic hacking. Instead, they believe it'll mean doing things the same way farmers have done them for thousands of years, just doing them better with modern science. Farmers have followed this ancient recipe for centuries. Select plants with the desired trait, cross-pollinate, pick the best offspring, and repeat. Very slow and not that precise. Wouldn't it be better if we could accurately pinpoint the desirable traits and control the cross-pollinated offspring to speed up this same ancient recipe? Researchers have sequenced the complete DNA genome of several crop species and done just that. In 2006, scientists identified a rice gene called Sub1. It comes from a variety that doesn't give much yield, but it allows rice plants to survive underwater for weeks. Cross-pollinate that variety with a more delicious one with a higher yield, and instead of waiting for them to grow up to see which carry the gene, just screen baby plants' DNA. Saves months, even years compared to the old way. And there's no time to waste because rising sea levels and more frequent floods are two of the most serious impacts of climate change. See, the world's poorest farmers are often on the most flood-prone land, and rice strains like this one could mean the difference between future feast or famine. Biotechnology like this, it's just a more high-tech version of what farmers have always done. These new ways of doing old things are showing a lot of promise, but some scientists think we should go the other direction and be even more aggressive with how we hack plant biology. They're trying to play with the biology of photosynthesis itself. Crops like corn and sugarcane do photosynthesis using 4 carbon molecules, while rice and wheat use 3 carbon molecules. And since C4 plants usually require less water and fertilizer, scientists are trying to re-engineer the C3 plants piece by genetic piece to make more with less in this hotter, drier world. The first green revolution saved 1 billion lives, but it wasn't perfect. The same few crop varieties spread around the world, and we lost a lot of local food diversity. Today, most of the world eats the same few things, and in the process, many of the world's most vulnerable farmers became dependent on expensive and environmentally contaminating pesticides and synthetic fertilizers. Local knowledge that was built from thousands of years of agricultural history was almost lost. Sure, science made their lives easier, but it also forced them to live a different way, and in an uncertain future, that might not work. Like most big scientific problems, the next green revolution won't have just one answer. It will involve old knowledge from people who know their land better than anyone else, using new science by people at the cutting edge of human progress, and probably a few crazy futuristic things we've never tried before. Because to keep up with how fast the world is changing, we have to plant as many ideas as we can in order to keep on growing. Stay curious.